Question 29. The following diagrams represent half cells. So these are half cells here. We're using, which of the following indicates the order of half cell reactions from lowest E0 value to highest. So what we need to know is from this information, let's get a chemical series happening. So what we need to know is that the positive is always going to be above the negative in an electrochemical series. So from this one, we've got the fact that the G forming G2 positive is above the Q forming Q2 positive. Okay, then we know from this one that the Q is above the J. So the J must be below the Q. There we go, because that's negative and that's positive. And lastly here, we know that the J here is above the R. So R must be here and the R below that. So here we have the order from the, the top of our electrochemical series to our bottom. So therefore it has to go, the highest E0 will be G, then Q, then J, then R. So which one of these fits our bill? G, Q, J, R. Answer's gonna be D. Fantastic. In the human body, not all energy is available for metabolism of the food. It is reasonable to deduce that in aerobic respiration. So I've got some equations here. And we just reading through this again. A student carried out further research and found that energy is used in the production of adenine triphosphate, ATP, to form all this information's a lot of stuff. So the formation of that is a hydrolysis reaction. Hydrolysis means breaking up a molecule with water. Water is a product here and here, so therefore that's not going to be right. If water was a reactant and we're breaking up a molecule, that would be right as well, but this is not, it's actually producing water. This would involve some calculation. The production of ATP is an exothermic. Exothermic means energy is being released. I remember reading that energy is used here, so that's not going to be right either. And now I need to do some calculations. So let me find my thing here, and I'm going to work out the fact that if we have this much CO2, so this much CO2, 3.3 grams, I should have that much ADP. So 3.3 divided by 44 gives me my number of moles of carbon dioxide. My ratio is 6 to 32, so I divide by 6 times by 32 and I get 0.4. That is good. That's fine. Let's just double check that this is not fine. I've got 9.5 grams of glucose, so 9.5 grams there. Now molar mass of glucose is here, so 9.5 divided by 180 gives me, that's my number of moles of my glucose there, which I'll move so you can actually see it. That's my number of moles of glucose. My ratio is 1 to 32. So if I times that by 32, I get 1.6, which is not 2. So my answer here has to be B, simply by eliminating out these things here first and then doing some quick basic calculation and looking at my ratios. Remember, dividing by the number you start with, timesing by the coefficient where you're going to. And that's it.